Hey everyone, so this is going to be a quick intro to using the mypy type checker to type check your Python 3 programs. If you're wondering, type checking in Python, it's kind of a big deal right now. A lot of people are talking about how this could potentially be the future of the language. And just to give you a feel of what type checking is actually good for. So this is a new feature that was added in Python 3.5. And what it allows you to do is, let's say we write a simple function, let's call it add this, and we just give it two arguments, a and b, and it's going to return a plus b, right? So in kind of stock Python, we don't really have a good idea of what the types are that this function deals with, and then also what the type of the return value is going to be. I mean, you could imagine that I can call this with two strings, and I can also call this with two integers, and I could call it with a bunch more things, and some of them might not even make a lot of sense. So what type hinting does now is it allows me to specify the expected types for these arguments and then also for this function. So I can say, okay, I expect these two arguments to be integers, and then I expect this function to also return an integer. And the way this works is that these guys here, these type annotations, they are a syntax extension that was added to Python 3.5. So this is not going to work in older versions of Python. There's a way to do that in Python 2 as well, and it involves, I think it works with some comment syntax, or basically putting these annotations into comments. You can look that up on your own. For now, let's focus on the Python 3 syntax. And basically, what these type hints allow me to do is specify like I said, the expected types for these arguments and also the expected return type. So right now, when you look at this, it doesn't actually guarantee that this function can really handle these argument types. It's just a type hint, or it's just these three type hints. And, I could just do this, where I just force this function to return a string, and it wouldn't really be an error, right? Like, matter of fact, if I save this and then just run it through the Python interpreter, let's actually probably call this and call this function. Then the program still works, even though it doesn't really follow this contract for the types that we gave it. Now, the way that types are going to be working in Python is that they're just type hints. And then you need an external program, almost like a linter. It's called a type checker. And you would need that type checker program to actually look at your program code and then give you feedback on whether or not your program code actually follows the type annotations, right? So in this case, this function would be violating its type annotations. And I'm going to show you now how you can actually run a type checker on this program. So a really popular type checker right now is mypy. So let's install that for a second. Pip install mypy.lang. You want to make sure you install mypy-lang, because just mypy without the -lang is something else entirely. So you're not going to be happy with that. Cool. So let's install mypy. It's going to take a second here. Okay, great. And now what I'm going to do is just run mypy on my types example.py. Cool. And we actually got an error message here, which is great, right? Because we knew that our program wasn't valid in the sense that it was following the type annotations. And so here, mypy tells us types example.py in function at this incompatible return value type got stir expected int. And this is pretty much exactly what we're saying here, right? And so we can fix that by changing it so it returns an int, right? Like we could either do something like that where we hard code it, and that would cause the type checker to pass, or we could, well, actually make it do something useful, like return the sum of these two. And then that would still pass. And you could see that, having this a plus b as the return value is actually a little bit more complicated than just saying return 23, because it's kind of easy for mypy to figure out that 23 is an integer constant. But when you actually do something like a plus b, then mypy has to go and check the type of a and check the type of b, and then actually figure out that if you add these two, you end up with an integer as well. So therefore, the type hints are accurate, and we don't get a type error. So you can imagine that this technique can be scaled quite well. And it actually already goes far beyond just that little experiment that I showed you, right? Because, if you look at this, like, this wouldn't be really interesting. Where it gets interesting is when you have thousands and hundreds of thousands of lines of code or millions of lines of code, and you can use a tool like mypy to actually find some really big bugs that were previously undetected. The type hinting stuff is going to get more valuable as you have more and more code, and as you're able to kind of automatically find bugs that would be really hard to detect for a human in a ginormous code base, right? And kind of the make or break thing for this to work is having these type hints already there for, let's say, large parts of the Python standard library or third-party libraries. And so, just to give you an example, like let's say I import the random module, and I'm going to change my add this function to do something terrible, which is we're going to go and just make it return a random integer between a and b. So now this still type checks cleanly, which means that mypy actually understands that random randint returns an integer. And it seems like really, really straightforward for a human, because we have the Python docs, and we kind of, we're told this thing returns a random integer in range a, b. But in a lot of cases, like in some cases, mypy might be able to infer that type and just figure it out on its own. But in a lot of cases, it's going to depend on people adding these type hints to functions in the Python standard library and also in other third-party libraries. So like a big bulk of the work is not just writing the type checker, which is, difficult enough. It's a big project, but also like a big bulk of the work is adding these type hints everywhere so that mypy and other type checkers can be as effective as possible. Because if a type checker doesn't know what the types are you're dealing with, it doesn't really add a lot of value, right? It could still function as like a basic linter, but it gets really interesting when you have all of these type checks. So there's a big project right now. I believe it's called the Type Shed project, where people add these annotations to the standard library to cover kind of as much of that as possible. And then also people are starting to incorporate third-party libraries like Django and kind of the big popular ones. And so, well, kind of how can I wrap this up, right? So because this was just meant to be as a small like intro video. So I think I see a lot of power in just having the possibility to do type checking in Python, because like I said in the beginning, it's going to enable a lot more use cases for Python as a language, which I think is awesome. And on the other hand, it's going to take a lot of work before this is really going to work seamlessly, right? Because if you do this stuff like that in a statically typed language like Java, then you're going to have to provide these types like from the get-go, right? So there never was a Java that didn't already have all of these types, and that's why the compiler can work with it and can give you all this helpful feedback. But for Python, it's kind of the unique challenge is that the type checking stuff is going to be bolted on to Python, And so now we're in the situation where you can already use this on a small scale, like for small programs, but it's going to take a little bit more time before actually all of the other code is going to be covered well with type hints. So you can actually really use this on a larger code base without actually getting tons of warnings and errors that aren't real errors that just happen because the type hints are missing or are ambiguous. So all in all, I think this is going to be a really interesting direction Python is going into. And if you're interested in this stuff, today or like now is probably a good time to get into it, because then you're going to be at the forefront of this new language feature.